Assalamualaikum and hello everyone. My name is Nurshifa binti Jamal. My metric number is 196683. Today, we are from Group 6 wants to do a video presentation for question number 5. Uh, we need to consider the nonlinear problem, minimize x1 plus x2 with subject to 4x1 plus 4x2 minus x1 square minus x2 square minus 7 greater or equal to 0, and the other constraint is x1 square less than or equal to x2. Okay, the solution is first to the constraint, we just brought x2 to the left hand side, which is x1 square plus x2 greater or equal to 0. Okay, first we need to transform the function of this problem, um, which is to penalty function. P x rk equal to x1 plus x2 equal to rk ln 4x1 plus 4x2 minus x1 square minus x2 square minus 7 minus rk ln negative x1 square plus x2. For this function, we use ln. Okay. Next, we need to find the first order necessary condition for optimum of PXRK is, this one is we need to differentiate with respect to x1. We got 1 minus RK bracket 4 minus 2x1 and 4x1 plus 4x2 minus x1 square minus x2 square minus 7 to the power of negative 1 minus RK negative 2x1 negative x1 square plus x2, and this one is to the power of negative 1, and we need to equal 0. Next one is differentiate p to the with respect to x2 equal to 1 minus rk 4 minus 2x2 4x1 plus 4x2 minus x1 square minus x2 square minus 7 to the power of negative 1 minus rk bracket negative x1 square plus x2 to the power of negative 1 equal to 0. And then from the we differentiate first with respect to x1. uh, we got one that uh, 4x1 plus 4x2 minus x1 square minus x2 square minus 7 to the power of negative 1. We make it as the denominator, which is to the power of 1, and we equal to 0, all of these. And then we make it 2x1 rk over negative x1 square plus x2 to the left hand side, and the two terms we make it to the right hand side, which is rk for 4 minus 2x1 to the power of uh, divide by 4x1 plus 4x2 minus x1 square minus x2 square minus 7 minus 1. And then 2x1 from left hand side, we bring it to right hand side, so that we got the denominator 2x1 1 over 2x1, and all of this we denote as equation 1. Yeah.
Hello friends, my name is Krishna Priya Karmanan and my metric number is 196490. I will continue the explanation of this solution. So after we get the equation number 1, we substitute equation number 1 into uh, the p that we differentiate respect to x2. So we get 1 minus rk 4 minus 2x2 over 4x1 plus 4x2 minus x1 square minus x2 square minus 7 minus rk 4 minus 2x1 over 2x1 4x1 plus 4x2 minus x1 square minus x2 square minus 7 plus 1 over 2x1 equal to 0. And then um, we take the rk 4 minus 2x1 over 2x1 to the other side of the equal. So we get the second equation, 1 minus rk 4 minus 2x2 over 4x1 plus 4x2 minus x square minus x2 square minus 7 equal to rk 4 minus 2x1 over 2x1 4x1 plus 4x2 minus x1 square minus x2 square minus 7 minus 1 over 2x1. By comparing the equation, we get 1 equal to negative 1 over 2x1. So we get our x1 value equal to negative 1 over 2. From dp dx1, we have 4x1 plus 4x2 minus x1 square minus x2 square minus 7 power of negative 1 equal to rk minus 2x1 minus x1 square plus x2 power of negative 1 minus 1 over rk 4 minus 2x1. So we uh, take the x1 negative x1 square plus x2 power of negative 1, we make it in the denominator, so we get power of 1 at the denominator. Next, substitute. So we get the equation number 2. Then substitute equation 2 into dp dx2. We get 1 minus rk 4 minus 2x2 rk minus 2x1 minus x1 square plus x2 over rk 4 minus 2x1 minus x1 square plus x2 minus rk minus x1 square plus x2 power of negative 1 equal to 0. Then we take the 1 to the other side, so we get the equation number 3.
Okay. Hi, my name is Noiza Afika binti Muhammad Zamri and my metric number is 199103. I'll continue. So from the previous solution where we get the equation 3, now we substitute the equation 3 into the we substitute x1 into the equation 3, which we will get rk4 minus 2x2 and the fraction rk minus 2, and we substitute from the previous solution where we compare it, and it will and we will gain this kind of uh solution. and we will equal it into 1. Then we simplify it and we will get RK 4 minus 2x2, RK plus 1 over 4 minus x2 over 5 RK minus 1 over 4 plus x2, and then we plus with RK minus 1 over 4 plus x2 to the power of negative 1, and it equals to 1. So the RK to the power of negative 1, we can make it as a denominator and it is to the power of 1. Then we will get 1 over RK, and then we simplify it to 4RK minus 2RK x2 and RK plus 1 over 4 minus x plus 5RK square over 4RK and minus 1 plus x2 in 1. So from the equation that we get it, the denominator we bring it to the right hand side. So we will get the solution as follow: 4RK minus 2RK x2, RK plus 1 over 4 minus x2, and plus with 5RK square, and it will equal to the previous denominator 5RK minus 1 over 4 plus x2. So from this solution, we expand the equation in the bracket and we will get 4RK square plus RK minus 4RK x2 minus 2RK square x2 minus 1 over 2RK x2 plus 2RK x2 square plus 5RK square, and equal to minus 5 over 4RK plus 5RK x2. Then we will simplify it, and we will get the last one, 2x2 square plus x2 in the bracket minus 19 over 2 minus 2RK and plus with 9RK plus 9 over 4. Then we will equal it to 0. Okay.
Okay, my name is Siti Donazura binti Tajuddin. I will continue for the next part. And for the next part, as we have already arranged it in the terms of x2, to get the x2, we use the quadratic formula, which we can see that for A is 2 and for B is negative 19 over 2, or negative 19 over 2 minus 2RK. For the C, 9RK plus 9 over 4. And then we sub into the quadratic formula. This is for the B part. What we get is 19 over 2. After we sub in the negative, it's become positive, which is 19 over 2 plus 2RK. And then for the B squared, what we get is 361 over 4 plus 38 RK plus 4 RK squared. And for the part negative 4AC, what we get is 72 RK minus 80. Okay, the result that we get is 19 over 8 plus RK over 2. This is after we simplify the 2A, and this is what we get: 19 over 8 plus RK over 2 plus minus square root of the 289 over 4 minus 34 RK plus 4 RK squared over 4. Okay, then from the previous part, we already get the x1 value, which is negative 1 over 2. And for the x2 we get is just now, the value just now. So from that, we only choose the minimum part, which is x1, which is the x2 part, is 19 over 8 plus RK over 2 minus that square root 1 over 4. That we only pick the minimum part. Okay, then continue with Afika.
My name is Afika binti Amar and I am matric number 196940. I will continue the presentation. So since we already get x1 and x2 just now, we need both the solution must be approached by the sequence xrk when rk approaching 0. So since x1 is constant, the limit is always negative 1 over 2, while for x2, we get the limit when rk approaching 0. We just substitute rk equal to 0 to the x2 value. Then this part will become 0. This part will become 0. This part will become 0. So 19 over 8 plus, minus 17 over 8. Square root of 289 over 4 divided by 4 is equal to 17 over 8, which will get 1 over 4. So x1 is equal to negative 1 over 4, x2 is equal to 1 over 4. And we find the minimum value of the function is x1 plus x2, negative 1 over 2 plus 1 over 4, which is equal to negative 1 over 4. It is actually the same as the actual minimum. Now, suppose we do the minimization process for various of RK value from 10, 1, 0.1, 0.01, 0.001, and 0.0001. Since RK approaching 0, so we need to choose the decreasing value of RK. So from here, we can observe that the smaller the RK that we choose, the good approximation for the actual solution. And as we can look here, finally we get when RK equal to 0, we'll get the actual solution. So that's all from us. Thank you.